Hello everyone, and then welcome to another tutorial video. So in this video we'll be treating integration by parts, okay, using the DI method. Say the DI method is one of the techniques most tutors, okay, most lecturers or most teachers do not teach their students, okay, but it's very helpful. Again, so in case you are new to this channel and you want to see more of these videos, or you want to improve grades, okay, in terms of what calculus, algebra and all that, I would urge you to subscribe to the channel, turn on the post notification so that you don't miss out on future or newly uploaded videos. Without further much ado, let's dive right into this video. So for the integration by parts DI method, I will just group it into three main methods, okay? So we look at the first method, second method, and the third method. Note that the third method is quite complex, so you need to stay with me till the end of the video so that you get to know how to simplify the method and help you, okay, understand the entire concept, okay? So let's start from the first method. So we have the method 1, okay? So for the method 1, it's just the basic integration approach, okay? So or integration question. So let's say you are given a certain integral. So I will show you the simple approach as to how to find the answer to this question, okay? Very simple and straightforward. So let's look at the DI method. So the D, as you might have guessed, is differentiation, and then I is integration. So this is what we'll be doing. We'll be picking these expressions, okay, and then group them into integrate and differentiate. It all depends on you, okay? It all depends on you. It's either you choose, it depends on how you choose the expressions, okay? So depending on how good your integration or differentiation is, you choose one specific function, and then you do you integrate, and then you choose the other one, and then you differentiate. So from here you could notice that this expression could be simply differentiated, okay? So we will differentiate that, and then this expression could be simply integrated. So we will integrate this. But before you do that, just write your plus minus, okay? Just in case, okay? Okay, so let's first choose differential. So we have s exponent 3, and then sine 2x will be we'll be integrating sine 2x. So now all you have to do is just keep on differentiating. So when you differentiate s cubed, you end up at 3x squared. You differentiate again, you end up at 6x. You differentiate again, you end up at 6, and then you end up with 0. Note that this positive corresponds to s cubed, negative corresponds to this. Positive corresponds to 6x, and negative corresponds to 6. Plus corresponds to this 0. Now let's integrate this, okay? Let's integrate this expression. So when you integrate sine 2x, you end up with minus 1 over 2 cos 2x, okay? And then after getting 1 over 2 cos 2x, you have to integrate this expression again, this same expression again. So when you integrate minus 1 over 2 cos 2x, you end up with minus 1 over 4 sine, okay, sine of 2x. Again, you would have to integrate this expression again. So when you integrate minus 1 over 4 sine of 2x, you end up at 1 over 8 cos of 2x, okay? Again, you just have to take the integral of this expression again. So when you take the integral of 1 over 8 cos 2x, that's when you end up at 1 over 16 sine of 2x, okay? Right, hope this was very simple. Okay, I've made it very simple. So notice that whenever you integrate, it affects these signs, okay, these negative signs, okay, just like that. Now note that this is what they correspond to, okay? So plus s exponent 3 corresponds to sine of 2x, minus 3x squared corresponds to minus 1 over 2 cos 2x, positive 6x corresponds to minus 1 over 4 sine of 2x, minus 6 corresponds to 1 over 8 cos 2x, and then 0 corresponds to 1 over 16 sine of 2x. Now, this is how you find the final answer for this question, okay? Pay close attention so that you get to understand. You have to multiply them diagonally, okay? So start from here. So this will correspond to this one. That's s exponent 3 will correspond to minus 1 over 2 cos 2x. Negative squared will correspond to minus 1 over 4 sine of 2x. Positive 6x will correspond to 1 over 8 cos 2x, and then negative 6 will correspond to 1 over 16 sine of 2x, okay? See how simple this is. So this will be your final answer, okay? So let's keep this in mind. Note, you have to keep these signs in mind, okay? operation sign, that positive, negative, positive, negative. So now positive corresponds to this one, so we have what? So you could either write what? Minus 1 over 2, and then you bring your s cube, okay, s cube, and then you bring your bracket, and then you have what? Cos of what? 2x, okay. And then you move on to the second one. Second one is what? Negative. So negative times negative is what? Positive. So we have what? Positive what? 1 over what? 4, okay. And then we have what? 3x squared. So you could just write what? 3, okay, on 4x squared, okay. Or you could just write this in bracket. It all depends on you, okay. You have what? Sine of 2x. So you bring your sine of 2x over here. Sine of what? 2x, okay. And then you move on to what? The next one is what? Positive 6x, what? Multiplying 1 over 8. So we have what? We have positive what? 6x, okay. So this could be written as 1 over 8, okay. And then you write what? 6x, okay. And then you have what? That's cos of what? 2x, okay. This is what I'm referring to. This is the expression I'm referring to. And then the last one is what? 6. So negative 6, okay. That's negative 6 divided by what? 16, okay, because that's what? 1 over 16. So, and then we have what? Sine of what? 2x, okay. I hope this was very simple, okay. Very simple and straightforward. So after this, you could just simplify, okay. You could just simplify this further. You could just write this is 3 on 4x squared, and then you could also write this as what? 6 on 8, where you could what? 3 on 4, okay, equals 2x, and then this will also be what? 3 on what? 8, okay, sine of 2x, okay. It depends on you, okay. All you have to do is just simplify this, and then you end up with what? The correct answer, okay. So let's look at the second method. I hope this first method was very simple and what? Straightforward. In case you did miss something, just go back to the video and then try to understand. So okay, so let's move on to the second method, okay. Now this is the second method. That's method 2, okay. Now, so let's say you are given another question. So let's say you are what? The integral of what? X exponent 3, okay, and then x exponent 3, and then ln of x, okay, and then let's add that dx. Now, for the second method, it's a bit complicated than the first method. I would urge you to pay close attention so that you get to understand. Now, for the second method, we'll be using the same principle, okay. Differentiate and what? Integrate. Again, you will need to choose your preferable what? Integral, and then what? Differential. So that means that the one you can easily differentiate and the one you can easily what? Integrate, okay. So from here you could know that you could easily differentiate ln of x, okay, and then easily integrate s exponent 3, okay. So let's do that. So let's bring up positive, negative, positive, and then negative, okay. So now we could easily differentiate what? Ln of x, and then we could easily what? Integrate what? S exponent what? 3, okay. That's the principle. It depends on you, okay. All you have to do is just choose the one you could easily what? Differentiate, and the one you could easily what? Integrate, okay. Okay, just choose the one you can easily differentiate and the one you could easily integrate. So now let's see how you go by this. So when you differentiate ln of x, okay, you end up with 1 over what? X, okay. And then when you integrate s exponent 3, you end up with what? 1 over 4 x exponent 4, okay. Now this is what I want you to keep in mind. Always choose a reasonable and easy function to integrate, as I initially stated, okay. That's why I stated that choose the specific expression you can easily differentiate and the specific expression you can easily what? Integrate. Now let's look at something over here. So from here you could notice that we could proceed to differentiate and integrate, but I want you to note something. Note that once you integrate, okay, once you integrate the product of a row, we stop, okay. This is what I mean. Once you can integrate the product of a row, we stop. So you can notice that this is a row, okay. 1 minus 1 on x, and then what? 1 over 4 x exponent 4 is a row. Once we could what? Integrate the product of the row. So once you could integrate the product of this, okay, you just stop. So this is how you solve this problem. Pay close attention. So we have what? This would be what? So we are trying to cross multiply, okay. So this would be what? 1 over 4. So we have 1 over 4, okay, and then we have what? X exponent what? 4, okay, from here, and then we have what? ln of x, okay? And then we will just rewrite this, okay? That's why initially I stated that once you could integrate the product of a row, you stop. So you could notice that we could integrate 1 over x multiplied by 1 over 4x exponent 4, okay? So we stop. So we have what? 1, the integral, okay? So we want to integrate. So the integral of what? The product of this row, the product of this row. So we have what? The integral of what? 1 over x, okay? And then multiplying what? 1 over 4 x exponent 4, okay, x, okay? You get to understand better once we do this. That's why I initially stated that you need to pay close attention. Once you could integrate the product of a row, you stop, okay? Because we could actually integrate the product of this row, okay? 1 over x multiplying what? 1 over 4 x exponent 4. Now let me show you how. So we have this will just remain the same, 1 over 4 x exponent 4, okay? And then we have what? Ln of x. But look at something over here. So when you multiply this, okay, when you do the cancellation, you notice that you could actually have what? So when you look at this, x will just cancel x out, so end up with what? 1 over what? 4 x exponent what? 3 dx, okay? You see how simple this is? Because x will cancel x, and then we will be remaining with what? X exponent 3, okay? That's why I initially stated that once you could actually integrate the product of a row, you just stop, okay? From here, after doing the diagonal multiplication, you ended up with this expression, and then we took the what? The integral of the product of this row, and then we ended up with this. Now, after cancelling the x out, we've ended up with this, okay? Now, you could notice that you could actually solve this, okay? Very, very simple. So we have what? Ln of x. Now, from here, when you integrate, okay? When you integrate the whole of this, you end up with what? This is 3, okay? So when you add that, you end up with 4. So we have 1 over what? 16. That's 4 for 16. So we have, and then x exponent what? 4. And then you have what? Plus c. Okay? This is how you solve this problem. So after doing this, you are done. Okay? This is the final answer for this problem. That's why I initially stated that you need to pay close attention to the terms and the concept so that you get to understand. Okay? So this is how you easily solve these kind of problems when it comes to what? Integration by parts. So for the method 3, let's say you are given what? This kind of what? Question. Okay? Let's say e exponent s, and then we have what? Cos of what? X dx. Okay? So this is your question, and then you are told to what? Integrate. Okay? So most definitely you'll be using integration by parts because this is what? Like a product rule. Now, again, you'll be using a DI method. Again, choose preferably the one reasonably to you where you could integrate, and then the one you could easily differentiate. So let's introduce our plus, negative, okay? So from here you could notice that we could actually easily differentiate e exponent x, okay? And then integrate cos of x. So we have what? E exponent x, and then we have what? Cos of x. So let's try differentiate e exponent x. So when you differentiate e exponent x, you end up with e exponent s. Again, you end up with what? E exponent x, as you already know. Now, when you integrate cos of x, you end up with what? Sine of what? X. And then when you integrate sine of, okay, when the function part repeat itself, we stop, okay? So from here, you can notice that this is the exact function, okay? E exponent s cos x dx, okay? E exponent x cos x is the exact function. Now, and then we are told that when the function part repeat itself, we stop. So that means that whenever you are differentiating and integrating, and then you come across where the function, a part of the function is repeating itself, you just stop, irrespective of the what? Operation signs, okay? So from here you have what? E exponent x, and then you have what? Cos x. And then from here you can notice that we have what? E exponent x cos x over here, but it's not. It's negative cos x. We don't pay close attention to what? The operation sign. Just concentrate on the what? Function part, okay? So now you can notice that we have the function part repeating itself. So we stop. That's for method 3. That's why I stated that you need to stay till the end of the video so that you get to appreciate this method, because it's a bit confusing. But once you pay close attention, you understand. So we have what? The function repeating itself. So we stop from here. So all you have to do is just use our diagonal what? Multiplication. Okay? And then we proceed from there. So from here we have what? Positive e exponent x, and then sine x. So we have what? From here we have what? E exponent x sine of what? X. And then we have what? Negative e exponent x, negative cos of x. So that will give us what? Positive e exponent x, and then what? Cos of what? X. And then, just as we did for method 2, we maintain this expression because it has repeated itself, okay? The function part has repeated itself. So we have what? This is what? Positive, this is what? Positive e exponent x minus cos x. So this will give us what? Negative what? Negative, and then we use our integral, okay? Negative e exponent x, and then we have what? Cos of x dx, okay? So all we have to do is just solve this problem, okay? Solve this part and then add it to this section, and then we are good to go. Now let me show you something. Since we have the same expressions over here, so we have our functions over here, e exponent s cos s and then e exponent s cos s, we could just add e exponent s ds from to the left side, from to the left hand side and what? Right hand side. So this is what I mean. This is the main expression, okay? This is the main expression, e exponent x, or the main equation. So e exponent s cos x dx equals what? E exponent x sine of x, okay? And then we have what? Plus e exponent x cos of x, and then we have minus what? The integral of what? E exponent x cos of x dx, okay? Dx. So let's add this expression to the left hand side and then right hand side. So let's add plus what? The integral of e exponent x cos x, okay, dx to this side, and then add what? The integral of e exponent x cos x dx to this side. So from here, we could notice that these two will just cancel out, okay, because this is positive e exponent, positive integral of e exponent s cos s ds, and then this is what's negative e exponent s ds. So these two will just cancel out, so we'll be left with this one, okay? So this will give us what? So this is what? The integral of e exponent s cos x plus the integral of e exponent s cos s. So this will give us what? 2 integral of what? E exponent x cos x, okay, dx, all right? And then this will be equal to this expression, okay, without this one. So we have what? E exponent x sine of what? X plus what? E exponent x cos of what? X. So from here, you could just further simplify. This is just algebra, okay? It depends on how you want to simplify this. For me, I would like to multiply 1 by 2 throughout this expression, okay? So that I'll get rid of these two, because this is the main what? Question, and then you want to arrive at the exact answer. So I'll just multiply this by what? 1 over 2. Multiply this expression by 1 over 2, and then multiply this expression, okay, by 1 over 2. So from here, you can notice that this will cancel this out. So we will end up with what? This integral e exponent x cos of what? X dx. Now our final answer will be what? 1 over 2 e exponent x sine of x, okay, plus 1 over 2 e exponent x cos of x plus what? C. So this will be what? Your final answer, okay? This will be your final. So you could either try to, factorize 1 over 2 e exponent x out, and then you end up with what? Sine of x plus what? Cos of x, and then outside the bracket you end up with what? Plus c. But it all depends on you, okay? It all depends on you. I hope this video was helpful, okay? So in case you want to see more of these videos, these integration, algebra, calculus, trace to help you get higher marks in what? Okay, algebra and calculus, I would urge you to subscribe to the channel, turn on your post notification, because these are the kind of videos we make available on this channel to help students augment their studies, okay? So in case you have any question throughout this video, let me know, or let us know in the comment section, and then we'll reply to them as soon as possible. Have a lovely day.